January 2026, Langley Air Force Base, Virginia. An F-22A Raptor from the 94th Fighter Squadron sits at 40,000 feet over the Atlantic Test Range. The pilot, call sign Titan 1, transmits a single word to the range controller: commit. He squeezes the trigger. Nothing happens. The missile doesn't release. A hydraulic warning light floods the cockpit amber. 13 feet of missile, 1,500 pounds, is hanging half-ejected from a modified weapons bay that was never designed to hold it. At this altitude, at this speed, he cannot land with an unsecured weapon. He has one pass to fix it. 1. The AIM-174B weighs as much as a small car. The F-22's internal bay was designed around a different weapons envelope entirely. What happens when you force a naval long-range missile into a stealth fighter's airframe is not theoretical. Titan 1 is living it right now, at Mach 1.2, with a hydraulic system bleeding pressure and a range safety officer on the radio asking for a status update. We will come back to Titan 1 and what he decided in those next 90 seconds. But to understand why the USAF put that missile in that aircraft at all, you need to know what the strategic geometry of the Pacific looked like 18 months earlier. The problem starts with math. F-22s, based at Kadena Air Base in Okinawa or Andersen Air Force Base in Guam, are the first line of intercept against any Chinese bomber strike package moving toward the first island chain. The H-6K, China's primary long-range strike bomber, carries the YJ-12 anti-ship missile with a range of approximately 400 kilometers. To intercept the H-6K before it reaches launch range, an F-22 must engage at distances exceeding 200 nautical miles from its own base. That means the AIM-120D AMRAAM, the Raptor's primary beyond visual range weapon, becomes a liability. Its practical engagement range in a contested environment tops out at roughly 100 nautical miles. The F-22 would have to close to within AMRAAM range of a bomber formation protected by J-20 escorts. That is not an intercept, that is a merge. In practical terms, the existing loadout creates a geometry where the F-22 must accept risk it was not designed to absorb. Naval Air Systems Command and the Air Force Research Laboratory identified this gap in 2023. The solution they arrived at was the AIM-174B. The AIM-174B began as a naval program. Its lineage traces directly to the SM-6 Standard Missile, a surface-to-air weapon originally developed for the Aegis combat system aboard U.S. Navy destroyers and cruisers. The SM-6 has a range officially listed at beyond 240 nautical miles in surface-to-air mode. Analysts at the Center for Strategic and Budgetary Assessments estimate the air-launched AIM-174B variant extends effective engagement range to between 300 and 350 nautical miles in an air-to-air profile. The missile uses an active radar seeker and terminal guidance, meaning it does not require the launching aircraft to maintain lock after release. The F-22 fires and turns cold. The missile finds its own target. What that means in combat: a single F-22 at Kadena can engage an H-6K formation before those bombers clear the Chinese coastline, before the first YJ-12 is ever armed. The intercept happens in Chinese airspace, or just outside it. No adversary air force currently has a doctrinal answer for that geometry. Here's what's most surprising about this program. The AIM-174B wasn't designed for the F-22 at all. The initial platform integration target was the FA-18EF Super Hornet. Navy test pilots at China Lake flew the first captive carry sorties in late 2024. The decision to extend integration to the F-22 came later, driven specifically by the Indo-Pacific intercept requirement and the Raptor's superior survivability in a contested environment. You don't send a Super Hornet into J-20 escort airspace. You send a Raptor. The engineering problem is significant. The F-22's internal weapons bays were designed in the 1990s around the AIM-120 AMRAAM, a missile roughly 6 feet long, weighing 335 pounds. The AIM-174B is 13 feet long, 1,500 pounds. The starboard main weapons bay required structural reinforcement of the forward trapeze assembly, the mechanical arm that ejects the weapon clear of the aircraft before motor ignition. A hung AEM-120 is a manageable problem. A hung AEM-174B at Mach 1.2 is a structural event. The fire control integration is equally complex. The F-22's AN/APG-77 AESA radar operates in the 8 to 12 GHz band with low probability of intercept waveforms. It was not originally coded to hand off targeting data to a naval seeker architecture. According to reporting by Aviation Week in March 2026, the software rewrite of the F-22's mission systems computer required over 18 months of development by Lockheed Martin and Raytheon engineers working under a classified contract. The challenge was not making the missile work. The challenge was making the Raptor's fire control system trust the missile's own terminal seeker without feeding it conflicting guidance data mid-flight. That matters because the AEM-174B's engagement geometry relies on a mid-course update package transmitted by the launching aircraft after release. If the fire control handshake fails, the missile flies ballistic. At 300 nautical miles, a ballistic miss is not a near miss. It is a complete mission failure. I spent time going through the unclassified Naval Air Systems Command program documentation from 2024 and 2025, and one detail kept appearing. The fire control integration challenge was flagged as a Category 1 technical risk as late as August 2025. That means the program office considered it capable of causing mission failure. 4 months later, according to a USAF program announcement in December 2025, the software integration passed its critical design review. That's a compressed timeline for a Category 1 risk closure. Subscribe. Next week, we're breaking down what China's J-35 carrier fighter actually brings to the Pacific equation. And the numbers are more concerning than the Pentagon briefings suggest. The RAND Corporation's 2025 Pacific Wargame Assessment, publicly released in summary form in February 2026, modeled a Chinese attempt to establish air superiority over Taiwan within the first 96 hours of a conflict. The model assumed standard F-22 loadouts: AIM-120D primary, AIM-9X Sidewinder for close range. In that scenario, RAND analysts concluded that F-22s based at Kadena would face a penetration problem. Engaging H-6K formations before launch required closing to within range of J-20 escort fighters. The exchange ratio was not favorable. The Raptor wins most of those engagements individually. It does not win all of them. And the U.S. Air Force does not have infinite F-22s. The total fleet stands at 183 operational aircraft. If you had to redesign the F-22's weapons loadout knowing what the Pacific geometry looks like today, would you make the same call the program office made? The AIM-174B adds capability, but it also adds a structural modification that cannot be reversed quickly in a surge scenario. That's the trade the USAF accepted. Here's the take that will get us pushback from some quarters. The AIM-174B integration is the right answer to the wrong problem. The real gap is not the F-22's weapons range, it's the F-22's numbers. 183 aircraft spread across global commitments with a production line that closed in 2011. The AIM-174B makes each individual Raptor more capable at long range. It does not solve the attrition math if China accepts a strategy of trading J-20s for F-22s at a 3-to-1 ratio. China is currently producing roughly 40 to 50 J-20s per year. The U.S. is producing 0 additional F-22s. That is the strategic context that RAND's February assessment placed on the SecDef's desk. The AIM-174B extends the engagement envelope. What that means in combat, it improves the opening exchange. It does not change the production differential that shapes the third week of a sustained conflict. The obstacle that nearly derailed the entire program was not the software integration. It was the structural qualification test. In October 2025, during ground-based ejection testing at Eglin Air Force Base, the modified trapeze assembly failed on the third test cycle. The forward lug fractured under asymmetric load. Engineers from the F-22 System Program Office had 72 hours to determine whether the failure was a design defect or a manufacturing variance in that specific component. If it was a design defect, the integration timeline collapsed. The answer came back at hour 68. Manufacturing variance. A single batch of titanium stock had been processed outside tolerance. New components were machined, tested, and certified within 3 weeks. The program stayed on schedule. The first live fire test sortie, the one involving Titan I over the Atlantic Range, was scheduled for January 14, 2026. The test plan called for a single AIM-174B release against a BQM-167 target drone, simulating an H-6K flight profile at 35,000 feet, 200 nautical miles downrange. The weapon would fly autonomous terminal guidance after a mid-course update at 150 nautical miles. Range safety required clean separation within the first 3 seconds of ejection. If the weapon did not achieve clean separation, the pilot had authorization to jettison over the range. Jettison meant the trapeze assembly fired a pyrotechnic charge to forcibly eject the missile. It also meant the weapons bay door frame sustained damage requiring depot-level repair. It meant months of delay. It meant the program office explaining a failure to the USAF acquisition chain. Titan I ran through his emergency procedures. Hydraulic pressure was dropping, not from a line failure, but from a seal that had been stressed by the abnormal ejection sequence. He had enough pressure for one more actuation of the trapeze. One attempt to complete the ejection sequence the right way, or fire the pyrotechnic and take the damage. He chose the trapeze. On the second actuation command, the AIM-174B cleared the bay cleanly. Motor ignition at 4 seconds. Mid-course update transmitted successfully at 150 nautical miles. The missile's active radar seeker acquired the BQM-167 target at 18 nautical miles. Impact confirmed. One detail from that test that stayed with me when I reviewed the program summary. The hydraulic seal that failed had been flagged during pre-flight inspection as within tolerance but at the lower end of the acceptable range. The crew chief noted it. The decision to fly was made by the test conductor. In the risk calculus of a weapons integration program, that is an acceptable call. In a combat scenario with no range safety officer and no recovery airfield within a reasonable divert distance, that seal failure has a different set of consequences. The F-22 will carry this capability into operational evaluation through 2026, according to USAF program office statements released in April. Initial operational capability is not publicly confirmed, but defense analysts at Jane's Defense Weekly, writing in May 2026, assessed IOC as likely before the end of the fiscal year. Will the AIM-174B integration reach full operational capability before China closes the J-20 production gap? Comment yes or no. The numbers are genuinely unclear, and we read everyone. The strategic implication is this. A flight of 4 F-22s with AIM-174B loadouts, operating from Kadena, can threaten a Chinese bomber formation at ranges that previously required land-based missile systems or naval surface combatants. The intercept geometry shifts westward, into airspace where the PLA-AF currently operates with near impunity beyond the first island chain. That changes the engagement calculus for H-6K mission planning. Chinese bomber crews must now assume that an F-22 they cannot detect on their own radar warning receivers is capable of engaging them at distances the AMRAAM could never reach. The F-22 first flew in 1997. Its production line closed in 2011. The platform is approaching 30 years from initial design. The AIM-174B extends its relevance into an engagement envelope that did not exist when the aircraft was conceived. The pilots who flew it in its original configuration, with its original loadout, know what the capability numbers cannot fully capture. The question the USAF has not publicly answered is whether a modernized Raptor with a 300 nautical mile missile changes the Indo-Pacific equation enough, or whether the answer to a J-20 production line running at 40 aircraft per year requires something built after 2011. The F-22 remains the most survivable fighter in the Pacific theater. For now, the question is not whether China will close the 5th generation gap. In production terms, they already have.